Alright guys, you made it to the last lesson, lesson 3.7, Systems of Inequalities, or the last lesson of chapter 3, I should say. Don't get too excited. So once you finish this lesson, you will work on the review and then the test. Alright, so this one is similar to lesson 3.6. However, this time instead of one graph, we're going to have two graphs. So we're talking about a system of inequalities, and as you can see here, a solution of a system of inequalities in two variables is an ordered pair that is a solution of each inequality system. So the graph of a system of inequalities is the graph of all the solutions of the system. So I put this example here for you guys and then realized that Big Ideas made a mistake. So I would like to explain their mistake. So when they did inequality number 1, your y value is greater. So this shading inside of here is correct. So that part's correct. However, when they did this one, y is less than x plus 1, for some reason they shaded the wrong side. So this blue part should not be shaded. It should have been this area should have been shaded, which would make this section right here. I was going to see if I could make it a different color. Here, I'll just highlight it. So it would make this section right here the solution set. So they had this part correct. It was just confusing because they shaded the wrong side of inequality number 2. So if you have questions about that, please ask, but we are going to look at some examples, so hopefully that clears it up. And I apologize, I wish I would have noticed they made a mistake before making copies of the notes. Alright, let's get started with example 1. We are graphing a system of linear inequalities. So we are graphing two linear inequalities this time. So these you should be really good at. Remember, we put it in the form of y equals mx plus b, where b is our y-intercept and m is our slope. So we've talked about this multiple times this year. Alright, so let's graph it. So step 1, we're going to graph our first inequality. So our y-intercept is 1, our slope is negative 1. So remember, if there's none, there's 1. So we're going to start off with our y-intercept and graph 1 on the y-axis. Now our slope is negative 1, so that means we are going to go down 1 and then to the right 1. So starting at this point, we're going to go down 1, over 1, down 1, over 1, and so forth. And then we can graph our line. Now, remember, because this is or equal to, that means our graph is going to be solid. So we are going to have a solid line going through the corner of all of the boxes. So do the best that you can. Mine aren't always pretty. Alright, so this is the Thank you. This is the equation. Y is less than or equal to negative x plus 1. So we need to know which side to shade. Because it says y is less than or equal to, that means that I should shade this. But remember, if you are ever unsure of which side to shade, let's pick a point. So I am going to use my favorite point right here, 0, 0. So I'm going to test 0, 0 into my first inequality. So remember, if it's a true statement, that means I shade this side. If it's a false, I shade that side. Alright, so is 0 less than or equal to negative 0 plus 1? Well, 0 is just 0, so 0 plus 1 is 1. Is 0 less than or equal to 1? Yes, so that is a true statement. So what does that mean? That means I am shading this side of my graph. So I know the green's a little hard to see, but I don't have another color option besides one other one that I'm going to use for the next part. So hopefully you get the idea. Alright, so now step 2 says to graph y is greater than x plus 3. So again, 3 is our y-intercept. X, there is no coefficient, so there is 1. So that means once we graph 3, we're going to go up 1 and to the right 1. So let's start off with 3. So 1, 2, this was 1, 2, 3. All right, and then we're going up 1 over 1. So it's going to go through the corner of all of those boxes. Now, keep in mind that because this one is not or equal to, it is not a solid line, it is a dashed line. So we're going to draw a dashed line for this one. Alright, so this is the graph. Y is greater than x plus 3. So now, because our values of y are greater, that means we should shade the above portion, or I'm looking at the wrong graph, I'm sorry, the above portion of this graph. But like I said, let's test a point. So again, I'm going to test 0, 0. If it's a true statement, that means I shade this side. If it's a false statement, that means I shade that side. So I'm going to test 0, 0 again, but this time with this one. So I'll just do it over here. Is 0 greater than x? Well, gotta plug in 0 for x, lady. 0 plus 3. So is 0 greater than 3? No, that is a false statement. So what does that mean? That means we do not shade the side that includes this. We shade the other side. So we shade this side. So now we have our two sides shaded. We are looking for the portion that overlaps. So if we look, this section right here overlaps with the green and the orange. So in both times, this little section right here was shaded. So this is our solution set. So all of the values that are in here, any ordered pair you pick would work for both of these inequalities. Okay, so you should have one of these papers that has 4 quadrants on it in your notebook. I just want you to do number 1 because you should have done linear functions before, and I want to focus more on the quadratic ones. But just for practice, please take that paper, try the graph of number 1, come back and we will talk about it. So pause your video now and go try it, even if you don't want to. Alright, so hopefully you gave it a try. Again, you did not have to do 2 or 3. I'm just going to go over 1. If you want to try 2 and 3, you can, and I can tell you if they're right in class, but I'm not going to go over them on the video. So you should have all this information, and we're going to start off graphing. I'm going to graph because some of you I know aren't that excited about it. So I have my y-intercept graphed, and then we're going to go up 1, 2, 3 over 1, and you're going to continue that. Now remember, your line is dashed, so go ahead, draw your dashed line, and I will be back. Alright, so you should have this drawn. Make sure you're labeling your graph since we have more than one with which inequality it is. Alright, so now we want to know which side to shade because it's less than. I'm assuming we're going to shade this side, but let's test 0, 0 because 0, 0 is easy to test and see if it works. So go ahead, if you haven't already, plug in 0, 0 and test it and see if it works. Alright, so I tested it. It works out. 0 is less than 2, so that means we do shade the side that includes the origin. Okay, so you should have that shaded. So now we're going to go and we're going to graph the second one. Alright, so if you haven't graphed it already, please try it now. Okay, so you should have this graph on your paper now. And again, an easy point we can test is 0, 0, but because it is y is less than or equal to, we're going to take a guess that this side is going to be shaded, but just to verify, we're going to test the origin. If you don't like the origin, you're welcome to test any other point. Okay, so when I tested it in this one, it was false. So what does that mean? That means we shade the side that does not include it. So we're going to shade this side. Alright, so we have that shaded. So what does this mean? This means this overlapping portion right here is our solution set. Alright, so like I said, you're welcome to try the other ones, but I want to focus more on the quadratic ones since you did these in Algebra 1. Alright, so we are going to move along to example 2. So now notice that we have one where we have a quadratic and a linear, and one with a quadratic and a quadratic. So we are going to do both. So if you would like to pause the video, because you should know how to graph these by now, and graph them and come back and see if you are correct, you are welcome to do that. And then if you are correct, you can fast forward through me telling you how to graph it. Okay? All right, sounds great. Let's move on. So let's start off with this first one. We're going to graph. So we know that there is no bx term. So when there is no bx term, that means in this situation our vertex is, for inequality number 1, is going to be 0, 4. We know this because there's no bx term. So you would plug in 0. If we plugged in 0, we would be left with 4. So our vertex is 0, 4. 1, 2, 3, 4. We know that our graph is facing down because it is negative. So now I just want to choose a point close. Since I have a lot of room to work, normally I would go 1, but I'm going to go 2 just for funsies. So I'm going to plug in when x is 2, what is y? All right, so we can change this to equals just for the time being. All right, so we got 2 squared we know is 4. So we have negative 4 plus 4. Well, what's negative 4 plus 4? 0. So when x is 2, y is 0. So we have this point here. Now we know that in this case our y-axis is our axis of symmetry. So if we know 2 away on this side, we know 2 away on that side. And so now we can draw our graph. Remember, because this is not or equal to, we are going to do a dashed line. So now we need to know which side to shade. So because it's greater than, I'm going to say that we are more than likely going to shade this part. But look, my favorite point to test is right here. So we are going to test 0, 0. So we'll plug it in here. So is 0 greater than negative 0 squared plus 4? So we know that cancels out. Is 0 greater than 4? No, it is not. So we definitely shade this side. Hopefully that's better than the green was. Okay, so now we're going to graph the second one. So the second one is linear, so we know our y-intercept is 2. If there is none, there is 1, so we know our slope is 1. This part, guys, y'all should get better at, and if all else fails, you know you're able to use Desmos for help. All right, so we're going to go up 1 over 1, and so that means my graph's going to go through the corner of all of the boxes. Because it's not or equal to, it is going to be a dashed line. So this is y is greater than x plus 2. So since it's y is greater than, I'm going to say we're probably going to shade this part up here. But to be on the safe side, we're going to test 0, 0 for that one as well, since it's down here. So if it is false, we shade up here. If it's true, we shade down here. So is 0 greater than 0 plus 2? Is 0 greater than 2? Nope, that one's false as well. So we are definitely shading this section up here. So what does that mean? That means that our solution set is all of this area where the purple and the orange are shaded. So all of this area here, I'll darken it with a regular pencil. So basically everything above this line except for what's inside the parabola. So all of this would be our solution set. All right, if you'd like to give this one a try now that we refreshed, you're welcome to pause it and give it a try. If not, I will talk it through. All right, so we have another quadratic function that doesn't have a bx term, so we know that our vertex is 0, 3. So let's start there. All right, we need another point. So is this graph facing up or down? This negative tells us it faces down. So you could try 1 or 2. I'm going to go with 2 just so I can have a little bit of a longer graph. So we're going to plug in when x equals 2, what is y? So y is equal to negative 2 squared plus 3. So we have negative 4 plus 3 So y equals -1. So when x is 2, y is -1. This part here should not be new. We've been doing this since day one. All right, so 2, -1 gives me this point here. My axis of symmetry, again, is my y-intercept. So I know if there's 2 away there, I got 2 away over here. And it is not or equal to, so that tells me my graph is a dashed line. So we have y is less than -x squared plus 3. All right, so we got 1 down, but we need to know where to shade it. So because it's less than, I'm going to say we're probably going to shade inside the parabola. But we have our Miss Gill's favorite point to test, so we're going to test 0, 0, just to be safe. All right, so is 0 less than -0 squared plus 3? Could you do this part in your head just to check? Yes, most of y'all could successfully do this in your head, and I'm okay with that. I just like to show it for your notes. So when you go back, you know how did you figure that out. All right, so why did I mark it? I guess because I was talking while I was writing. This is a true statement. 0 is definitely less than 3. Don't know what you're talking about, lady. So 0 is definitely less than 3. So we would shade the inside of our parabola like we assumed we would, or guessed we would. We had an educated guess, or Miss Gill did. All right. Now let's do this one. So this one we do actually have a bx term, or a bx term, so we can find the vertex. We know this -3 is our c value, so this gives us our y-intercept. So we have a y-intercept right here again. And so now I need to find my vertex. So if you remember from chapter 2, we talked about how to find your vertex. So you have to find the x value, -b over 2 times a. So that's what we're going to do here. So we have -2 over 2 times 1 gives us -2 over 2, which equals -1. So we know that our vertex starts with -1 comma something. How do we find that something? We plug in -1. So I'm a little short on space up there, so I'm going to move down here and do that. So what is y when I plug in -1 for x? So again, I'm just finding my vertex, so we have another point to work with. All right, so -1 squared gives me +1. 2 times -1 gives me -2, and then I have -3. So y equals 1 minus 2 is -1, minus 3 gives us -4. You're welcome to put that in a calculator as well. So now we know our vertex is -1, -4, and because there's no negative, our graph faces up. So let's find -1, 1, 2, 3, 4. All right, so now our axis of symmetry is right here, right, where -1 is. So if we know this is 1 point away, we have another one right there. This one's or equal to, so that means I can make my line solid. And now, because it's greater than or equal to, sorry, there was like a little lag there, I'm going to assume we're shading up here. Now this one at origin's a little tough to tell if it's included, so I'm going to use this point right here, which is -1, 0. All right, so in this situation, I'm not going to test the origin. I'm going to test -1 comma 0. So we still test it the same way, it's just not as easy as 0 is. So y is 0, so is 0 greater than or equal to 0 squared plus 2 times 0? Or no, lady, you're plugging in the wrong number again. One day I'll get it together. We're plugging in -1. This is our x, this is our y, just so Miss Gill remembers. All right, I'm so used to testing negative or 0, 0. So -1 squared plus 2 times -1 minus 3. Sorry, I'm running out of room there. All right, so -1 squared gives us 1, so we're saying is 0 greater than or equal to 1. 2 times -1 gives us -2, -3. So 1 minus 2 minus 3 gives us -4. So is 0 greater than -4? Yes, it is. So that means we do shade the inside of this parabola. So what does that mean now? That means our solution set is this combined area that overlaps right here. So this is our solution set. All right, so now I'm gonna have you try to. So in a moment, you're gonna pause the video. I'm gonna give you some inequalities and that extra paper that I gave you. I want you to do it. All right, let's challenge ourselves. Let's go with question number 8 and question number 10. So those are the two that we are going to add to our paper. So you need this paper again, and you're going to do question number 8 and 10. I would like for you to pause the video and give it a try on your own. And I'm going to stop the video there and start a new one just in case.